Good day everyone, this is Sir Fred and welcome to another video lesson tutorial.
Good day everyone. Today, I'm going to discuss equation of a circle. Let us get to know first the following objectives. At the end of the lesson, you should be able to derive the equation of a circle, write the equation of the circle given its center and radius, and find the coordinates of the center and the length of the radius given its equation. In equation of a circle is drawn with its center at the origin O and radius R. As a proof, show that the equation of the circle is x raised to 2 plus y raised to 2 is equal to r raised to 2. As we all know, for any point P represented by x, y on the circle, we can represent segment OP as r. And from that, if Q is a point represented by x, 0, forming a right triangle with O and P, then segment OQ can be x and segment PQ can be equal to y. Using the Pythagorean theorem, we can say that segment OQ squared plus segment PQ squared is equal to segment OP squared. Substitution of the representation from the segments, we have come up with x raised to 2 plus y raised to 2 is equal to r raised to 2. On our next slide, suppose a circle is not centered at the origin, but the center C is the point represented by h, k. We need to prove that the equation of the circle is the quantity x minus h raised to 2 plus the quantity y minus k raised to 2 is equal to r raised to 2. Just like the first proof, for any point P represented by x, y on the circle, we can represent segment CP as equal to r. And from that, the vertical distance from point C to point P can be represented by y minus k, and the horizontal distance from point C to point P can be x minus h. And using the Pythagorean theorem, we can say that the quantity x minus h squared plus the quantity y minus k squared is equal to segment CP squared. And upon substitution, we have come up with the quantity x minus h squared plus the quantity y minus k squared is equal to r squared. From the two proofs that we have shown, we have come up with the standard equation of a circle. So if the circle is at the origin, we are going to use the equation x squared plus y squared is equal to r squared, where r is the radius of the circle. And if the circle is not at the origin, we're going to use the standard form, the quantity x minus h squared plus the quantity y minus k squared is equal to r raised to 2, where the center of the circle is h, k. Let us take a look at this equation. We have x raised to 2 plus y raised to 2 is equal to 9. So take note that 9 here is r raised to 2. Getting its square root, we have come up with r, which is equal to 3. The center of the circle is at the origin and the radius is equal to 3. Now, let's graph this circle. Using this Cartesian coordinate system, the center of this circle is at the point of origin, which is 0, 0, and count out 3 in all directions since that is the radius, and sketch the graph. So that is the graph of x raised to 2 plus y raised to 2 is equal to 9. If the center of the circle is not at the origin, then the equation for the standard form of a circle looks like this. Let us take a look at this example. We have the quantity x minus 3 raised to 2 plus the quantity y minus 1 raised to 2 is equal to 16. So here, your h is 3 and your k is equal to 1. Getting the square root of 16, your radius is equal to 4. So now, the center of the circle, which is h comma k, is 3 comma 1 and the radius is equal to 4. If we are going to graph this circle, we have the center which is 3 comma 1, count 4 in all directions, and sketch the graph. On the following set of examples, we are going to write the equation of the following circles with a center at the origin which is 0, 0. So we have radius which is equal to 4. As we all know, the equation of the circle at the point of origin which is 0, 0 is x raised to 2 plus y raised to 2 is equal to r raised to 2. So given that the radius is equal to 4, so we have come up with the equation of the circle which is x raised to 2 plus y raised to 2 is equal to 4 raised to the power of 2. And by that, the equation now would be x raised to 2 plus y raised to 2 is equal to 16. In our second example, following the same pattern, we have x raised to 2 plus y raised to 2 is equal to 5 raised to 2. Hence, the equation now would be x raised to 2 plus y raised to 2 is equal to 25. And in our third example, given the radius is equal to 6, so following the same equation, we have x raised to 2 plus y raised to 2 is equal to 6 raised to 2. We have come up with x raised to 2 plus y raised to 2 is equal to 36. Same case applies for our fourth example. So again, the equation of the circle, given that the center is at the origin, is x raised to 2 plus y raised to 2 is equal to r raised to 2. Our radius is 9, so therefore, we are going to have x raised to 2 plus y raised to 2 is equal to 9 raised to 2. So we have x raised to 2 plus y raised to 2 is equal to 81. And in our last example, so we have x raised to 2 plus y raised to 2 is equal to 10 raised to 2. And by that, we have come up with the equation x raised to 2 plus y raised to 2 is equal to 100. In this particular slide, we're going to find an equation of the circle with a center 0, 0 and a radius of 7. So what are we going to do? We are just going to plug in the center and radius values in the standard form. So that's why we have come up with x raised to 2 plus y raised to 2 is equal to 49. For this example, find the equation of the circle with a center at 0, 0 that passes through the point -1, -4. Since the center is at 0, 0, so we are going to use the equation x raised to 2 plus y raised to 2 is equal to r raised to 2. So the point -1, -4 is on the circle. So we should work when we plug it in the equation. So we're just going to substitute -1 to x and -4 to y. So squaring the 2, we have come up with 1 for -1 squared and 16 for -4 squared. The answer is equal to 17. So 17 here is equal to r raised to 2. And upon replacing 17 to r raised to 2, we have come up with the equation, x raised to 2 plus y raised to 2 is equal to 17. So here, we are going to find the equation of the circle with center 0, 0 that passes through the points which is from 1, 2. So again, the center is at the origin, so we're going to use x raised to 2 plus y raised to 2 is equal to r raised to 2. Since we have these points, just replace it with x and y. So we have 1 raised to 2 plus 2 raised to 2 is equal to r raised to 2. That is for us to identify the radius of the circle. So here we have 1 plus 4 is equal to r raised to 2. So your r raised to 2 is equal to 5. So replacing 5 here from r raised to 2. So we have come up with the equation x raised to 2 plus y raised to 2 is equal to 5. So this is the equation of the circle. For this example, we are just going to find the equation of the circle with center at negative 2, 5 and a radius of 6. So what we are going to do is to plug in the values in the standard form. So we have from the quantity x minus h squared plus the quantity y minus k squared is equal to r squared. We have come up with x minus negative 2 plus y minus 5 is equal to 6. Simplifying, we have come up with the quantity x plus 2 squared plus y minus 5 squared, that is equal to 36. So this is the standard form of the equation of the circle. So here we're going to find the equation of the circle with center at 2, negative 3 and a radius of 6. So we have here the standard form of the equation of the circle. So we are going to replace h by 2 and k by negative 3. Since we have 2 consecutive negatives for k, so we are going to change the sign into plus. So here we have the standard form of the equation of the circle as the quantity x minus 2 squared plus the quantity y plus 3 squared is equal to 36. For this particular slide, we are going to write the equation of the following circles given its center and its radius. So here we have the center which is at 4, 9 and the radius which is equal to 4. So as we all know, we have here the standard form of the equation of the circle given at h, k as its center. So we have x minus h raised to 2 plus the quantity y minus k raised to 2, and that is equal to r raised to 2. So the center is 4. We are just going to replace h by 4. Then we have for 4k, that is equal to 9 raised to 2, and of course 4 raised to 2, that is equal to 16. So this is the standard form of the equation of the circle. So for our second example, applying the same rule, so we have x minus negative 10 squared plus y minus negative 3 squared is equal to 5 squared. So from that, we have come up with x plus 10 raised to 2 plus y plus 3 raised to the power of 2, and that is equal to 25. So this is the standard form of the equation of the circle. And on our third example, so we have the quantity x minus 5 raised to 2 plus y minus negative 13 raised to 2 is equal to 2 raised to 2. And from that, we have come up with this standard form of the equation of the circle, which is the quantity x minus 5 raised to 2 plus the quantity y plus 13 raised to 2, and that is equal to 4. So for our last set of examples, so same rule applies. We are going to use the standard form of the equation of the circle, which is x minus h raised to 2 plus y minus k raised to 2 is equal to r raised to 2. So replacing h, we have x minus negative 4 raised to 2 plus y minus 0 raised to 2 is equal to 6 raised to 2. So from that, we have come up with x plus 4 raised to 2 plus y raised to 2 is equal to 36. So for example number 5, given the center at 0, negative 6 and a radius of 10. Okay, so we have x minus 0 raised to 2 plus y minus negative 6 raised to 2 is equal to 10 raised to 2. And from that, we have x raised to 2 plus y plus 6 raised to 2 is equal to 100. So this is the standard form of the equation of the circle. For this particular problem, find an equation of the circle with center at 8, 2 and passes through the point 8, 0. So again, plug in the center values in the standard form. So we have the quantity x minus 8 squared plus the quantity y minus 2 squared is equal to r squared. Since it passes through the point at 8, 0, we can plug this point in for x and y to find r squared. Okay, so we have 8 minus 8, open and close parenthesis, squared plus the quantity 0 minus 2 squared is equal to r squared. So 8, okay, and 0 comes from this particular given. And from that, we have come up with 4. Since 8 minus 8 is 0, 0 squared is equal to 0. And 0 minus 2 is negative 2, negative 2 squared is equal to 4. So here, we have r squared, which is equal to 4. And from that, we're just going to replace r squared by 4. So we have here the standard form of the equation of the circle, which is the quantity x minus 8 squared plus the quantity y minus 2 squared is equal to 4. In this particular problem, we're going to identify the center and the radius and sketch the graph. So here we have 9x squared plus 9y squared is equal to 64. So of course, to get in standard form, we don't want the coefficients on squared terms. So let's divide everything by 9. So dividing everything by 9, it will yield to x squared plus y squared is equal to 64 over 9. So remember to get the square root of 64 over 9 to get the radius. So here we have come up with x squared plus y squared is equal to 8 over 3. So from there, the center is 0, 0. Okay, that is from x squared plus y squared, and the radius is 8 over 3. Of course, don't forget to sketch the graph once we are done identifying the center and the radius of the circle. For this particular problem, we're just going to identify the center, radius, and sketch the graph of this equation. So remember that the center values ends up being opposite sign of what is with x and y, and the right hand side is the radius squared. So here we have the opposite sign of 4, that is negative 4, and the opposite sign of 3, of negative 3, that is 3. So from that, the center is negative 4, 3, and getting square root of 25, that is the radius, which is equal to 5. Again, sketching the graph, this is the standard form and the graph of the equation of the circle. For this particular problem, we're going to find the center and the radius of the circle of the equation. The quantity x plus 2 squared plus the quantity y minus 4 squared is equal to 50. Of course, getting the opposite sign of h and k, that is the center. So we have negative 2, comma 4, which is from 2 and negative 4. And of course, getting the square root of 50, so that is equal to 5 square root of 2. So this is the center, and this is the radius of the circle. So for this particular problem, we're going to find the center and the radius given this equation of the circle. So for our first one, we have x raised to 2 plus y raised to 2 is equal to 49. So as we all know, we are at the point of origin, which is center at 0, 0. And getting the radius, we have square root of 49, that is equal to 7. So this is the radius, and this is the center for our first example. For our second example, again, okay, so the center at 0, 0, radius is square root of 25, that is equal to 5. So here the center is at 0, 0, and the radius is equal to 5. For our third example, so we have center, get the opposite sign of the given equation. So we have from negative 9, that's 9. From negative 7, that is 7. Okay? So now, getting the radius, that is equal to square root of 36. That is equal to 6. So here we have the center and the radius of the circle. For our fourth example, we have, again, the center is the opposite of the signs from the given. We have negative 5, 6. And of course, the radius is equal to square root of 81. That is equal to 9. For our fifth example, okay, so the first component for our center is 0. And the opposite sign of negative 4, that is 4. The radius is equal to square root of 4. That is equal to 2. And on our last example, the center is the opposite of the signs from the given. We have negative 3. Okay. And for y, we have 0. For our radius, we have square root of 50. And since we all know that one of its factors is a perfect square, which is 25 times 2. So we have come up with 5 square root of 2. This is the radius and this is the center. Okay, so remember class that sometimes the equation of the circle does not always comes with the standard form. In this particular example, this is what we call as the general form of the equation of the circle. So just in case we're going to find its center and radius as well as its standard form, first thing that we are going to do here is for us to start, okay, completing the square on both x and y's to get it in a standard form. Okay, so group, okay, x terms and place to complete the square, same as with y, and we are going to move the constant term on the other side of the equation. Okay, so now to get, okay, to get this term to complete the square for x, we're going to divide the middle term by 2. Okay, as well as with y. So 4, no, divided by 2, that is equal to 2 squared, that results to 4. And from here, we have negative 8 divided by 2, that is equal to 4. 4 squared, that is equal to 16. So of course, whatever you added on the left side of the equation, that should also be added on the right side. And simplifying them, of course, we are going to get the square of binomial, okay, for the groups of x and y. Okay, and from that, we have come up with the factored form of this particular equation, that is getting the square root of the first term, that is x, getting the square root of the second term, of the last term, that is 2, So the quantity x plus 2 squared plus square root of the first term, that's y, square root of the last term, that is 4. Copy the sign of the middle term, that's minus. So the quantity y minus 4 squared, that is equal to 4. So this is the standard form of the equation of the circle. So here we have an example similar to the previous slide. Find the center and radius of the circle, which is x squared plus y squared plus 6x minus 4y minus 3 is equal to 0. From here, we must complete the square on both x and y's to get in the standard form. Okay, so group x and y's, and of course, move the constant on the other side of the equation. So divide 2 from the middle term. We have 6 divided by 2, that's 3. 3 squared, that is equal to 9. So here, negative 4 divided by 2, that is equal to negative 2 squared, that is equal to 4. So add the same values on the right side, so that becomes 3 plus 9 plus 4. From here, we have come up with the quantity square root of x, that x squared, that is x, square root of 9, that is equal to 3. Copy the sign of the middle term, that is plus squared. Continue, we have square root of y squared, that is y. Copy the sign of the middle term, that's minus. Then we have square root of 4, that is equal to 2 squared. Then add everything on the right side, so 3 plus 9 plus 4, that is equal to 16. So this is the standard form of the equation of the circle. So from that, the center is the opposite. So that is negative 3, 2. And the radius is equal to 4. That is square root of 16. So for our last and final set of activity, we're going to match the equation to the center and radius of the circle. So we have here for column A, the general form of the equations of the circle. And for our second column, we're going to identify which among them corresponds to its center and its radius. So let's begin with the first one. So again, we're going to group. Okay, according to x and y. So here we have come up with x squared plus y squared minus 6y. So just leave blank for it. For this term needs to be completed as perfect square trinomial. And of course, transfer the constant, that becomes 16. Okay, so copy x squared plus y squared minus 6y. So divide the middle term by 2, that is negative 3. Then squared, that is equal to 9. So here we have 16 plus 9. Okay, get the square of binomial of this term. So we have the quantity y minus 3 squared, that is equal to 25. Okay, so here we have the center, which has 0, comma, get the opposite of negative 3, that's 3. And the radius, okay, which is square root of 25, that is equal to 5. Okay, so that is on our fourth choice. Okay, so for our second example, so we have group according to x and y. So we have x squared minus 12x plus blank. Then we have plus y squared plus 14y plus blank is equal to negative 84 plus blank plus blank. Okay, so we have x squared minus 12x. Okay, so negative 12 divided by 2, that is negative 6 squared, that is equal to 36, plus y squared plus 14y. Okay, 14 divided by 2, that is equal to 7. 7 squared, that is equal to 49. So we're going to add also that particular value on the right side of equation. Okay, so from that, of course, get the square of binomials of the groups of x and y. So we have square root of x squared, that is x. Copy the sign of the middle term. square root of 36, that is 6 squared. Then we have square root of y squared, that's y. Copy the sign of the middle term. Then square root of 49, that is 7 squared. That is equal to 1. So that is negative 84 plus 36 plus 49, that is equal to 1. From here, the center is at 6 comma negative 7, of course, and its radius is square root of 1, and that is equal to 1. So this is our answer. Okay, so for the third one, so we have x squared plus 8x plus blank plus y squared minus 4y plus blank is equal to negative 11 plus blank plus blank. So of course, we need to get its perfect square trinomial by completing the square. So that is equal to, okay, x squared plus, so we have 8 divided by 2, that is equal to 4. 4 squared, that is equal to 16. Then, followed by y squared minus 4y divided by 2, that is equal to negative 2 squared, that is equal to 4. So you're just going to add it also on the other side of the equation. So that's negative 11 plus 16 plus 4. Okay, so now from this perfect square trinomial, so we have come up with square of binomial. So we have x, copy the sign of the middle term, get the square root of the last term, that's 4 squared plus y minus 2 squared is equal to negative 11 plus 16 plus 4, that is equal to 9. And from here, the radius is square root of 9, which is equal to 3. And our center is equal to negative 4 comma 2. So this is our answer. So now let's proceed to the next. So here we have x raised to 2 minus 4x plus blank plus y squared plus 6y plus blank is equal to 276 plus blank plus blank. So, of course, completing the square, we have come up with x squared minus 4x plus 4. That's negative 4 divided by 2 squared. That is equal to 2 squared. That is equal to negative 2 squared. That is equal to 4. Then we have y squared. 6 divided by 2. That's equal to 3. 3 squared. That is equal to 9. Okay, so that becomes 276 plus 4 plus 9. Okay, so gets its square of binomial. So that is x minus 2 squared plus y plus 3 squared. That is equal to 289. Okay, so our center now is at 2 comma negative 3, and our radius, so that is square root of 289, that is equal to 70. So this is our answer. Now for our last and final example, so we have x squared plus 2x plus blank plus y squared minus 18y plus blank is equal to 18 plus blank plus blank. So from that, of course, get or completing the square rule, So that becomes x squared plus 2x plus 1. That is 2 divided by 2 squared. That's equal to 1 plus y squared minus 18y. So negative 18 divided by 2, that's negative 9 squared. That is equal to 81 is equal to 18 plus 1 plus 81. Okay, so from that, square root of binomial, x squared, copy the sign of the middle term, square root of 1, that is equal to 1 squared, plus square root of y squared y, copy the sign of the middle term. Then we have square root of 81, that's equal to 9 squared. So we have 100. And from that, our radius is square root of 100, that is equal to 10. And our center is at negative 1, 9. So this is our answer. So always remember that the equation of the circle is defined and expressed in the form of the quantity x minus h squared plus the quantity y minus k squared is equal to r squared. Okay? And if the center is at the origin, so we're going to use the equation x squared plus y squared is equal to r squared. And by that, thank you class for listening and see you on our next lesson.